your Google Classroom. So if you wanted to print this up and follow along on the notes, you could, or if you wanted to do it that way. You'll notice that it says optional. There's no points affiliated with it. It's just for your convenience if you wanted to go through it. And maybe at the end I will post these all finished. I don't know. We'll see. So what we're talking about today is X and Y intercepts. And really, what an X or a Y intercept is it's just these points on a graph where the graph of an equation, say the graph of this equation right here,
ED is 16 centimeters.
crosses the y-axis or the x-axis. Any point on the x-axis would be considered an x-intercept, right? That line is intercepting that graph. So this point right here is an x-intercept, right? This point right here would be considered a y-intercept because it's crossing the y-axis. Now, the x-intercept has a lot of different names. You can call it an x-intercept. It's a lot of times it's called a root. It's called a zero. I'll explain why they'd call it a zero in just a second. And they also call it a solution to the equation, right? Because all of these graphs are just a visual representation of an equation. When I say zero, we call it a zero because technically this is what x is when y is zero. So if this is 1, 2, 3, -3, and notice we're not going up or down from the line, so our y value would be 0. And zeros of functions are what we consider the solution. It's how we solve these. What happens when y is 0 is what we consider to be the solutions of any function equation. And the idea is it gives us this fixed area that we can line up for everything, right? Let's make y 0 and we'll make all those our solutions so that we have this definitive line where we know things are going to line up, right? We don't call y-intercept zeros, even though if you look at any point on the y-axis, our x value is 0, right? But our y value is not. It'd be 1, 2, 3, 4, right? Still, there's always a 0 in it, but it's our input that's a 0, not our output. We consider x's to be inputs and y's to be outputs, right? So y always depends on x. Can you hear Miss Walters in the background teaching? She's very animated today. So if you think about it in terms of zeros, this next part where we're talking about finding intercepts algebraically makes a lot of sense, because when we find our x and y intercepts, if you read the instructions, it says to find the x-intercept of an equation, set y equal to 0 to solve for x, right? And if we look up at this, it says to find the x-intercept, we set y equal to 0. Well, that makes sense, right? When you realize that on this line that is x, every point is going to have a y of 0. And that means something algebraically, right? That means that I can set y equal to 0 and then solve and find where that x is going to cross. So if we looked at this equation right here, y equals minus 2x plus 5, and I wanted to find the x intercept, I'm going to set y equal to 0. So I'm going to have minus 2x plus 5 equals 0. And then I can find the x-intercept just by solving that out, right? I'm going to subtract the 5, and I get minus 2x equals negative 5. And then I can divide out that negative 2 that's being multiplied to the x. And I'm going to get x equals, a negative over negative is a positive, so I can just write this as 5 halves. I don't have to put it as negative 5 over negative 2. But that means that 5 halves, I'm going to have my x-intercept. That is my x-intercept. That's my point on the x-axis where the graph of this line, and this is a line, crosses the x-axis. If I want to find the y-intercept, I'm going to do the opposite. I'm going to make the x equal to 0 in the equation. So here I have minus 2. Oops, I want to turn that into a 0. I don't know how to erase on this thing yet. I got a new whiteboard, which is awesome, except for I got to learn how to use it. Look, it made my thing go away. Oh no. All right, that's a good thing to know, that I can't erase on it. So we're looking at this diagram here. Dang, man. But we're looking at this triangle and this triangle. Those are the two triangles that we're trying to prove. Okay, I just learned something very valuable, right? We found our x, and our x was equal to 5 halves, right? Was it 5 halves or 2/5? It was 5 halves. And so we're finding our y now, so we're going to go y equals negative 2, and we're going to set our x equal to 0 this time, plus 5. Well, negative 2 times 0 is just 0. So we're going to be left with y equals 5. That means if I was going to graph that, I would know that, okay, we'll call this 1, which means 2/5 would be somewhere like in here, like about 1/5 of it, right? So we'll call that 2/5. And we know at y equals 5, which would be somewhere up here, we would have another point. And then anytime we have 2 points, we can graph a line. And so just like when we were using the slope intercept form where we had that y-intercept and we found that point, and then we would count out the other point using the slope, this gives us 2 points too, right? It gives us a point on x and it gives us a point on y. And anytime we have 2 points, we can go ahead and graph that line. So it's super handy. So let's look at some of these and graph them. Hopefully we won't get too many fraction answers because they're really hard to graph on these tiny little graphs. But it says find the x and y intercept of each equation and then graph the equation using the intercepts. You will have to do both of those things on Delta Math, right? You'll have some where you're the first like 7 problems you only have to find the x and y intercepts, and then the next like 5 you have to find them and graph them. So if I want to find the x-intercept here, I'm going to set y equal to 0, right? So we'll call that the x. So we're going to go y equals 0. So I'm going to have 5x minus 1 equals 0. And I'm just going to solve this for x. So I'm going to add 1 to both sides. And I'm going to be left with 5x equals 1. Awesome. I'm going to have 1/5 because I've got to divide out that 5 now. I'm going to have x equals 1/5. What does that mean? That means I have a point like 1/5 in on this graph. I would love to not be opening up all of these weird things every time I touch this. I have to get used to this now. So we'll say that's about 1/5. It's really like 1/2, but this is a really tiny graph. I can't get to 1/5. But we've got the general idea. Our y-intercept, we're going to have the same thing, only this time we're going to go y equals 5 times 0, because we're setting our x equal to 0, equals -1, which always works out nicely because this is always going to equal 0, right? 5, anything times 0 is 0. So we know that we have our point on y at -1. And I see that these points are really close together, but it doesn't matter if I can draw a straight line through them. We can see that the graph of our line just goes through those 2 points. Not so bad, right? Now, if I look at number 2, I know I'm being told to find intercepts, which sucks because it's already written in slope intercept form. It makes it really easy to graph. And there's a couple things that I know, like I know that the y-intercept on this is 2, because that's what y equals mx plus b means. And you can see why, because when we're looking for the intercept of this equation, we know that when we set x equal to 0, we get our y-intercept. And if I multiply anything times 0, right, I would be getting 0 here. And so this would just be y equals 2. But we'll go ahead and do the math on it anyways. And we'll start with our x-intercept, right? Which says that we are going to set our y equal to 0. So we're going to have -6/5 x plus 2 equals 0. And we're going to start undoing everything that's being done to our x value. So I'm going to start by subtracting 2 from both sides so that I have -6/5 x equals -2. Now I have this fraction on here, which I know looks like it kind of sucks because you're having to deal with a fraction. But anytime you want to pull a fraction off of something, just multiply times its reciprocal, which means I can take this whole thing and I can multiply it times -5/6. I just have to do it on both sides, right? And these cancel, they become 1, and we're left with x equals, and I can go -2 times -5 is +10 over 6. And all I have to do now is reduce that fraction. So 10 divided by 2 is 5, 6 divided by 2 is 3, and I have 5/3. I am tired of these fractions for this. 5/3 is like 1 2/3. So it's going to be like a point somewhere over in here that I can't draw very accurately because I have a tiny graph. But I don't have to be accurate. I just have to be general. For our x-intercept, our y-intercept, I could tell you right now because we know what y equals mx plus b means, right? We know that this b means it's our y-intercept. But we'll go ahead and do the math on it. We'll go y equals -6/5 times x, which we're making 0, plus 2. And we get y equals, well, -6/5 times 0 is 0. And so all we're left with is 2. And we know our other point is going to be here on the y-axis. And we can just draw a line through those points, pretend that I actually made it through that point. I'm not good at drawing straight lines. Does that make some sense to you guys? Are you kind of getting the feel for it? I see one head bob. I only see 2 heads on the entire screen anyways, so I'm going to assume that everybody else is totally getting it. Now I have others I could bring in. I don't know where the other part of this sheet went, but do you guys need more examples, or do you feel pretty good about the examples that we've done? Because I have more examples right here, I just don't have them written down on there. So, but since nobody is asking for more and more, I'm going to assume you guys are getting it with this. If you need more, let me know. I guess I could always do a video, like a little short video, posting some other examples for you guys. But they are pretty. They all follow the same pattern, right? When you want to find your x, set y equal to 0 and solve. When you want to find your y-intercept, set x equal to 0 and solve, right? And when you want to graph them, just plot those 2 points and connect them with a line that goes through both of them. So that is the basics of what we're going through today. I told you it was going to be a relatively short lesson for you guys, simply because we're just finishing up the stuff we didn't get to in this section last week. But that is really all I have for you. Please let me know, though, if you need me to do some more examples. I'll stop the video, though, at this point, and